Hello. So I'd like to give a little opening speech about data storage. We'll dive into the nitty-gritty shortly. Questions about data storage are implicit in the data life cycle. The version of the cycle we've presented doesn't have an explicit storage step. You certainly need to have settled on storage decisions before the management stage because you can't manage data you don't have stored somewhere. But most of the time, its proper place is way back in the planning stage. And that's because storage is more than a file type. Like whether you call your data file a JSON and format it one way or a CSV and format it another way. Questions of storage are intimately linked with what you're doing with the data. For example, are you going to be constantly updating the data? If so, maybe a CSV isn't the most convenient way to store it. Maybe you want a database. How big are our storage demands? Spreadsheets work well as long as you don't have too many lines and too many columns, but they break down when the data gets too big. What are our security requirements? And I forefront these questions because I'm sure, taken CSV files and imported them into Python or imported them into R. I mean, we've all seen data storage, but in those courses, storage is often done rather carelessly because you get the data after somebody else has stored it and the stakes are low. If your intro to Python professor gives you a fake data set and you lose it, well, you can just go back to Canvas and download it again. And if you lose your laptop, or if somebody steals your laptop, well, that data set's fake. It doesn't have any confidential data in it. So, from a security point of view, it doesn't really matter. But what's true of these intro to Python or intro to R courses is not true in general. And it's essential that we unbreak some habits. I had a friend once, have a friend, who got access to confidential data for a paper, but he took this confidential data and he just dumped it on his laptop. No encryption, no security. And I learned recently that years after the project was finished, he still had that data floating around. And if his laptop ever gets stolen, the company he was working for is in for huge legal liability, as is he. So you don't want to do that. And similarly, these intro classes are misleading because projects in them have very clean beginnings and ends. You have a data file, you write the script, it cleans the data and does whatever, and then outputs a result. The question of what happens to the data in the meantime never really has to be explored beyond a vague and false idea that the changes you're making are being stored in Spider or RStudio. Questions of how to delete the data are never really forefronted because whatever, you leave it on your computer or you stick it in your recycling bin. Again, there are no security issues at work in those intro classes. For this class, for the data lifecycle and app development, that's no longer going to be sufficient. I mean, speaking of apps, you have a fitness app that's storing information about your body weight. Where is that data living when the app is closed? Is it on the phone? Is it in the cloud somewhere? Both of these have pros and cons. So proper storage is a lot more than knowing how to type df equals pd.read underscore csv data.csv. And people get entire master's degrees in things like cloud architecture or digital security. We have a week, so this is going to be a light overview. But in this unit, we will discuss local storage and online storage. So you at least have some idea what the factors in play are.